Okay, so imagine this someone trying to pump the entire Pacific Ocean
Ooh!
through a system of pipes.
Like, seriously, the whole thing.
That's the scale we're talking about today as we dive into this wild world of ocean carbon removal.
Pretty ambitious, right?
Right. And we've got a whole stack of research and articles here, including this deep dive from iSpectrum, to help us understand how these startups and scientists are planning to pull it off. Essentially, there are two main approaches.
Yeah.
Pulling CO2 directly from seawater,
Okay.
and then helping the ocean store even more carbon naturally.
So two very different approaches, but with the same goal.
Exactly. So let's start with a company called Captura,
Okay.
this marine tech startup based in Hawaii.
Interesting.
Their plan is to pump massive amounts of Pacific Ocean water
Massive.
through their system to capture CO2.
Wow.
And their pilot plant is actually set up on a repurposed U.S. Navy barge
You're kidding.
docked in the port of Los Angeles,
No way.
which used to be a hub for fruit and cotton trade.
So a complete shift in industries.
Yeah, I know. Pretty fascinating.
Yeah, that is.
What I find really cool is how they're adapting existing technology in a totally new way.
Right.
They're using electrodialysis,
Oh, yeah.
a process commonly used in desalination plants,
Yeah.
but with a clever twist to capture CO2.
I'm intrigued. Tell me more.
So instead of making fresh water, they're making,
What carbon dioxide traps?
well, not exactly traps, but they're creating an acidic solution that reacts with the dissolved inorganic carbon
Okay.
already present in seawater.
Gotcha.
And this converts it into CO2 that can then be collected.
So they're tweaking a known process to tackle a whole new problem.
Exactly. But what are the potential downsides of messing with seawater at a molecular level like this?
That's a great question. One of the big challenges is understanding the long-term effects of releasing that CO2-depleted water back into the ocean.
Right, because the idea is that it will then absorb even more CO2 from the atmosphere.
Exactly. But it's not quite that simple.
Because the ocean is a complex system, right?
Absolutely.
It's not like a swimming pool where you can just add chemicals and expect them to disperse evenly.
Right. Ocean currents, temperatures, wind.
Yeah.
All these factors influence how quickly that upper layer of water can reabsorb CO2 from the air.
So how can they even be sure it's working?
Good point.
It sounds like proving the effectiveness of this approach might be tricky.
It definitely requires a lot of monitoring and modeling. Companies like Captura rely on sophisticated numerical models, like ROMS and MARBL,
Okay.
to predict and assess the impact of their work. These models, developed by university and government researchers, take into account a vast array of oceanographic data to simulate how these changes might play out over time.
So it's like a virtual ocean.
Yeah.
Where they can test out different scenarios
Exactly.
and see what happens. But what about real-time monitoring?
Right.
How do they keep tabs on the actual changes happening in the ocean?
That's where sensor technology comes into play. They need sensors to measure things like alkalinity, pH, dissolved inorganic carbon, and the partial pressure of CO2. Some of these sensors, like those for pH and CO2, are already available, but others are still under development. The goal is to have a network of sensors providing real-time data, allowing for ongoing monitoring and adjustments as needed.
So it's like a constant back and forth between
Yeah.
modeling and real-world data,
Right.
trying to make sure everything is moving in the right direction.
Yeah.
But Captura isn't the only player in this field, right?
Not at all. There are a number of other companies exploring different approaches to ocean carbon removal.
Okay, so let's dive into those.
Mm-hmm.
Tell me, what are some of the other strategies being explored? So we've been talking about directly capturing CO2 from seawater, but you mentioned other companies are exploring different strategies. What else is out there?
Another fascinating approach is ocean alkalinity enhancement. This method focuses on boosting the ocean's natural ability to absorb and store carbon.
Okay, so instead of pulling CO2 out, they're helping the ocean hold on to even more of it. How does that work?
The idea is to increase the alkalinity of the seawater. This has a chemical effect, converting dissolved CO2 into stable carbonate ions.
So it's like locking that carbon away for good.
Essentially, yes. Those carbonate ions can remain stable for thousands of years. A couple companies are working on this using different methods. One is Vesta, and they're actually adding olivine sand to beaches.
Adding sand to beaches? That sounds surprisingly simple.
It is in concept. Olivine is a common mineral that naturally weathers and dissolves in seawater, and that process increases the alkalinity.
So they're essentially speeding up a natural process to boost the ocean's carbon storing capacity. Are there any downsides to adding all that olivine? Like, does it disrupt the natural balance of the beach ecosystem?
That's a valid concern. Anytime we intervene in a natural system, we need to carefully consider the potential impacts. Another company, Ebb Carbon, is taking a different approach using electrochemistry to increase ocean alkalinity.
Electrochemistry, so more of a high-tech approach compared to just dumping sand on the beach.
You could say that Ebb Carbon's system uses electricity to change the chemical composition of seawater, making it more alkaline.
Interesting. So both Vesta and Ebb Carbon are trying to achieve the same goal, but with very different methods. What are some of the challenges with this whole alkalinity enhancement approach? It seems like it could have unintended consequences, messing with the delicate balance of the ocean.
You're right to be cautious. One concern is the potential for ecological disruption from high concentrations of alkaline effluent.
Meaning that changing the alkalinity too drastically could harm marine life.
Exactly. And then there's the issue of public perception. People hear dumping chemicals and get nervous, even if those chemicals are naturally occurring minerals like olivine.
So transparency and careful regulation are key, like we talked about with Captura. But it sounds like these two approaches, direct capture and alkalinity enhancement, are pretty different. Are there any companies trying to combine them?
There is one that stands out, Aquatic. They've developed a system that blends direct air capture with marine storage.
Okay, a hybrid approach. What's their strategy?
Their system pulls seawater in and splits it into components using a specialized electrolyzer. The key innovation is that their electrolyzer avoids producing toxic chlorine gas, a major concern with traditional methods.
So they've tackled that environmental hazard, but how does this help with carbon capture?
Those separated components are then used to capture CO2 directly from the air. So they're pulling it out of the atmosphere and then storing it in the ocean where it naturally reacts with minerals to form stable carbonates.
So it's like a double whammy, capturing from both the water and the air. Do we know how effective this is? How much CO2 are they actually removing?
Their pilot plants located in both Los Angeles and Singapore remove about 100 kilograms of CO2 per day.
That's impressive. But I imagine scaling up is a huge hurdle for all of these companies. 100 kilograms is a drop in the bucket compared to the gigatons of CO2 we need to remove.
Scaling up is definitely a challenge. It requires a massive investment in infrastructure research and development.
And there are economic considerations too, right?
Yeah,
Who's going to pay for all of this?
Absolutely. And that's where government policies and incentives come into play. Governments can help create a market for carbon removal technologies, making them more financially viable.
So it's not just about the science and engineering, it's also about economics and policy. This is getting complicated.
It is complex, but the important thing is that these companies are all working towards the same goal, tackling climate change.
And it's fascinating to see the different paths they're taking to get there.
What I find encouraging is the collaborative spirit within this field. Even though these companies are vying for funding and recognition, they ultimately understand that they're all in this together.
Right, and as we've been discussing, ocean carbon removal, while promising, isn't the only solution. It's just one tool in the toolbox.
Exactly. There's no silver bullet when it comes to climate change.
We spent a lot of time talking about these high-tech solutions for removing carbon from the ocean. But it feels like we need to zoom out a bit, Look at the bigger picture of climate change. What else is being done?
Yeah, I totally agree. Ocean carbon removal is just one piece of the puzzle. We need to be exploring all the tools in the toolbox, including land-based solutions and renewable energy.
Okay, let's talk about land-based solutions then. What are some of the key strategies there?
One of the most straightforward is reforestation and afforestation, basically planting more trees.
That makes sense. Trees absorb CO2, so more trees means less carbon in the atmosphere. But can planting trees really make a dent in a problem this big?
It absolutely can. Studies have shown that restoring degraded forests and planting new ones could remove billions of tons of CO2 from the atmosphere every year.
Wow, that's huge. Plus, it just feels good to plant trees. Everyone understands that. Are there other land-based solutions that can have that kind of impact?
There's also soil carbon sequestration. It turns out soil is a massive carbon sink, and sustainable agricultural practices can help it store even more.
So how do we turn soil into a super carbon storing machine?
Practices like no-till farming, cover cropping, and crop rotation all help build healthy soil. Think of it like creating a sponge that can soak up CO2 from the air.
So working with nature instead of against it. It's a theme we've seen with some of the ocean carbon removal approaches too. What about renewable energy? It feels like that's a huge part of the solution.
It absolutely is. Solar, wind, and geothermal energy are becoming more and more cost competitive with fossil fuels. As we transition to these cleaner sources, we'll significantly reduce our greenhouse gas emissions.
It sounds like there's a real momentum shift happening there. But even with all these land-based solutions and this shift to renewables, it still feels like a massive problem to solve.
It is, but we can't let the scale of the challenge paralyze us. Every action we take, every bit of progress we make moves us closer to a solution.
So what's the takeaway for our listener? What can they do besides maybe planting a tree or two?
Individual actions absolutely make a difference. Simple things like reducing energy consumption, choosing public transportation, or biking instead of driving and eating less meat all contribute to a more sustainable future.
And it's not just about our own personal choices. We can also support businesses and organizations that are prioritizing sustainability and advocating for policy changes that accelerate the transition to a clean energy future.
Exactly. It's about collective action. Each of us making conscious choices, using our voices, and supporting those who are working towards a more sustainable world.
So as we wrap up this deep dive, what are your final thoughts?
I think this exploration of ocean carbon removal has shown us that there's no single answer to climate change. It's going to take a combination of innovative technologies, sustainable practices, policy changes, and individual action. It's a complex challenge, but it's not insurmountable. We have the tools and the knowledge now. It's about putting them into action.
Well, that's a great note to end on. It's been an incredible journey exploring both the cutting-edge science and the broader landscape of climate solutions. We've covered a lot of ground, but this is just the beginning of the conversation.
Absolutely. And the most important question we can ask ourselves now is, what role will each of us play in creating a more sustainable future?